All right. Good morning, First LEGO League teams. Are you excited? Awesome. Well, Space Center Houston is excited too to be hosting this kickoff of the First LEGO League Challenge into orbit. My name is Casey Hines, and I'm an education manager here at Space Center Houston and a former First LEGO League coach. I was thrilled to learn that all levels of FIRST Robotics had a space exploration theme to them this year because it is the mission of Space Center Houston to inspire all generations about the wonders of space exploration. The Manned Spaceflight Education Foundation is a nonprofit education foundation with extensive science education programs and an exploration center. We host evening education programs, overnights where you can sleep next to space-flown artifacts, field trips, and our immersive 5-day engineering design program called Space Center University. We are the official visitor center of NASA Johnson Space Center and a Smithsonian affiliate. After collaborating with local FLL senior mentors, we knew that Space Center Houston would be the perfect venue to host a kickoff event, as it's our objective to share NASA and space industry missions, and this season, your mission is about space exploration. We have a very exciting morning lined up that includes hearing from space industry experts, a quick message from the International Space Station, then afterwards everyone can head out to the astronaut gallery to see the new playing field for yourself. Are you ready for launch? Okay, well, we are going to start off with an out-of-this-world panel of experts to have a discussion about the challenges of space exploration. We want you to start getting ideas on how to overcome your space-related obstacles and how working as a team is critical to the success of your mission. So first up, I'd like to introduce Anjay Stewart, a satellite system engineer. Anjay is an experienced spacecraft operator for a wide variety of NASA missions. He's worked as a spacecraft mission controller for NASA's Mars Orbiter Fleet, the Juno mission to Jupiter, the Twin Grail lunar spacecraft, and the Spitzer Space Telescope. Anjay now works in mission control at the Johnson Space Center, developing tracking and navigation operations for upcoming missions for the Orion spacecraft. Anjay has earned degrees in aerospace engineering from the University of Texas at Austin and the Massachusetts Institute of Technology. And he aspires to be a NASA astronaut. And in pursuing that goal, he's had the opportunity to become a simulated astronaut serving as the flight engineer of the Human Exploration Research Analog, or HERA, a 2-week asteroid mission simulation at the Johnson Space Center, and as chief engineering officer of the High Seas, a year-long Mars mission on the Big Island of Hawaii. So please welcome Anjay Stewart. Next up, we have Tiffany Swarmer, who's a NASA Crew Systems trainer for the International Space Station. Tiffany grew up as an Air Force brat and spent her early years exploring the U.S. from coast to coast with her family. She earned a Master's of Science degree in Space Studies from the University of North Dakota and a Bachelor of Science in Biology from Sonoma State University. Tiffany worked with NASA's Flight Analogs team as a lead for the Human Exploration Research Analog, or HERA, and the crew medical officer and lead EVA specialist in a 120-day Mars analog simulation. This was also done through the Hawaii Space Exploration Analog Simulation, or High Seas program. She worked closely with the University of North Dakota's Human Spaceflight Laboratory to develop and test planetary spacesuits concepts and analog lunar and Martian habitats. Currently, she works at NASA's Johnson Space Center as a crew systems trainer for the International Space Station. Thank you, Tiffany. And last but not least, we have Chris Matty, an Orion System Manager. Chris Matty is from a U.S. Air Force family at Arnold Air Force Base in Tennessee. He grew up tinkering, modifying, and building all types of machines, as well as hiking, mountain biking, and rock climbing. Chris has a bachelor's degree in aerospace engineering from the University of Oklahoma and a Master's of Science in Astroparticle Physics from the University of Houston at Clear Lake. Chris has over 12 years of experience with the International Space Station and Orion programs, and is currently working at Johnson Space Center as a system and project manager for development, test, and build of Advanced Environmental Control and Life Support Systems for Human Spaceflight. In May 2016, Chris served as a flight engineer for the Hera 10 Deep Space Analog Mission. Please welcome Chris Maddie. So at this time, each presenter is going to have a few slides to share of their story, and then we'll dive deeper into a discussion. So Angie, we'll start with you.
Thank you, Casey. So there's a couple of points I want to make through my presentation here, one now and one towards the end. The first one here is you're about to hear three stories, three different ways that folks got to NASA here at Johnson Space Center. The point is this: there's no one single way to get here. There's no set of boxes that you can check to get to NASA. Find the thing that inspires you, find the thing that pushes you, and follow that. There's no one way, there's no one three ways. There are many ways to find your dreams. So my story is this. I started out as an Air Force brat as well. We've got 3 Air Force brats here today. Definitely proud of that fact. Makes you resilient, makes you chase opportunities. You learn how to adapt, how to live. And as part of that, as a child, I kind of went back and forth between wanting to be an astronaut and wanting to be an Air Force test pilot. Turns out I didn't quite have the eyesight to be a test pilot, so I ended up going the academic route, kind of played to my strengths a bit. Ended up at the University of Texas at Austin, so hook 'em horns. Spent 4 years there. It was a great experience. It really kind of pulled me out of my shell a bit. I didn't just learn aerospace engineering there. I learned how to be proud of something, how to be part of a team achieving something bigger than the sum of just the people. From there, I went to Massachusetts Institute of Technology, where I studied aerospace engineering again and also played a lot of ice hockey. I'll admit I wasn't the best grad student in the world, but it was still a great experience. From there, I had a couple of different jobs starting out. Spent my first year after school at Draper Lab in Cambridge, Massachusetts. There I was doing design work for the Trident missile guidance system and working on a lunar cockpit. From there, came to Houston for a couple of years and worked as guidance, navigation, and control on the Orion program doing spacecraft design. But kind of really where I hit my stride was after that, whenever I ended up back in Denver, Colorado. I became a flight controller for interplanetary space probes. So the entire Mars fleet, the Spitzer Space Telescope, Juno, Grail. The nice thing about working in this is they're very small spacecraft teams. From day one, you're thrown into the thick of it. So we didn't have training simulations there. We learned how to fly these spacecraft while working on the actual spacecraft. And with these things, we're doing amazing feats of engineering. While I was there, I got to help park a spacecraft into orbit around Mars. We got to take pictures of a comet flying by the planet. We got to take a spacecraft destined for Jupiter, fly it back around the Earth, and slingshot it out to Jupiter. Just the experiences we had here were amazing. And for many people, this would be sort of the highlight of your career, just getting to do all these cool things. But while I was there, I had coworkers who knew I wanted to be an astronaut. And one of them pointed me in the direction of the Hera program here at the Johnson Space Center, and so kind of threw me into a new trajectory. I simulated astronaut route. So on the, let's see, where'd I put it? On the left there, that's Hera. That's right here at JSC in Houston. Spent 2 weeks there. If I recall correctly, Tiffany was actually one of my trainers for that mission. And spent 2 weeks basically living life like astronauts will as they're heading out into deep space. That means extreme isolation, sensory deprivation, learning to live with less. And it sounds like a difficult experience, and in some ways it is, but I enjoyed it so much that I ended up doing it again, this time for a year. 366 days in that dome there on the right, perched on the mountain on the side of Hawaii, the volcano Mauna Loa. So after this experience, again, to kind of learn what it is to be crew, you can only do that for so long before you kind of have to rejoin the real world and get a real job again. So, first I wanted to introduce you to my crewmates. On the left, my Hera crew, to the right, my High Seas crew, and realize while I was in there, these were the only people I got to interact with. These were my brothers and sisters for, on the left, 2 weeks, and for, on the right, a whole year. But coming back, having to get a real job, so here I am at Johnson Space Center. Mission controller, so I'm learning how to navigate. And what that means is taking radar signals and communication signals of the spacecraft, figuring out where that spacecraft is in space. In addition, I'm still a test subject. So NASA uses me for various experiments. I give blood a lot. I'm scared of needles, and I'm kind of using it to get over that fear. The astronauts get to practice eye exams on me. I get to eat a lot of space food, so it's a cool job. The other thing I wanted to point out too is, here's the other lesson I wanted to come to, is succeeding in finding the things you want to do. It's not always about constant success, one win after another. You're going to lose along the way. You're going to sometimes have to learn how to work hard and push through, or sometimes kind of find a way around it, get creative, and find a different way to find your dreams. And so I'd mentioned earlier that I wanted to be an Air Force pilot. So I don't get to fly those cool F-16s, but I recently joined the Civil Air Patrol as well. And I'm now getting to fly airplanes for the United States Air Force. Not in a combat role, but in a humanitarian role, helping with disaster recovery, introducing youth to flight. So those were the two takeaways, is realize that you need to follow your motivation and be sort of, I guess, flexible. Understand that sometimes you're going to lose, and don't let that discourage you. And then maybe you can spend some time up in a place like this as well. I'm looking forward to hearing the other two speakers we have. Tiffany and Chris are absolutely amazing folks, and I'm sure you all enjoy them too. Thank you.
Thank you, Angie. All right, Tiffany, we'll have you come up next.
Well, good morning. It is an honor for me to be here talking to you guys at the first LEGO League Challenge. I am so excited to be here. Probably should put my presentation up though. Sorry guys, I was too excited. So as Casey said, I got a Bachelor's of Science in Biology, but I had always loved spaceflight, loved it. But I wasn't an engineer, and I wasn't really sure that there was going to be a place for me in this field. So I started to, after I finished my degree, I started to look around a little bit, and what I found was a program at the University of North Dakota where I could get a master's in space studies. So I arrived at North Dakota, and I got a chance to work with this beautiful analog habitat here. Now this is the inflatable lunar Martian analog habitat. So it inflates around a rigid steel structure, and it basically houses 3 to 4 crew members for anywhere from 10 to 30 days. And I just thought this was absolutely the coolest thing I had ever seen. So I started to look around because I knew this is exactly what I wanted to do. So I started to look around at the university, and I saw that they had a human spaceflight lab. Now, the human spaceflight lab works mostly with developing analog planetary suits, as well as what they call intravehicular activity suits, so what astronauts will wear when they're inside the capsule. So I approached the gentleman, you can see him here up at the top, Pablo de Leon. I approached him and I said, hey, I want to volunteer. I want to work with you guys. And he said, okay, what can you do? And I said, I am a biologist. And he said, what else can you do? So I told him, I'm an EMT. And he went, okay, I don't really need a biologist EMT right now. So I looked at him and I said, what do you need? You tell me what you need. And he said, I need somebody to do that stack of paperwork over there. And I said, oh yeah, you betcha. I'm going to go ahead and do that. So I, for about 6 months, did the administration work, did the paperwork, did the IRB. I'm not going to lie, it was pretty boring. But every day I got to go in and see these suits. Every day I got to work on a team that worked on these suits. And then at the end of 6 months, I got the chance to be a spacesuit tester. And it is as awesome as it sounds. I basically got to get in these suits and test them out for performance, engineering constraints, usability, all sorts of different factors. It was wonderful. While I was at UND, I got the opportunity like Anjay, to work with the high seas. Only I spent 120 days, so 4 months instead of a full year. And ultimately, as you can see, it's up on the slopes here. So you can see this picture here. It's showing you it's on the slopes of Mauna Loa, about 8,500 feet up. It is powered by solar power. And me and my crew, you can kind of see some of, you can see up here, there's the picture with the sunset. That was our only window to the outside. I can tell you at nighttime, it was competitive to see that. And then we also had plenty of living space. What did we do while we were there? We did a lot of work. We did a lot of planning for work. We grew plants to supplement our food. One of the more complicated things that we had to do was waste and trash management. I know that doesn't sound like a big deal, but when you're talking about 4 months, a year, 2 years, waste and trash management is going to be a big deal. And of course, we had May the 4th while I was in the habitat, so we had to celebrate appropriately. While I was there, I found one of my true passions, and that really was planetary extravehicular activity, both research, concept of operations, and planning. So you can see these suits here, when they're weighted up with ice and water and all of the things that you're going to need, these suits come in about 45 to 50 pounds. And we're walking around on relatively rough and steep terrain. So it was something that was really tough to do, but was one of the most worthwhile things I got to do. After the UND and the high seas, I started what any graduate does and started hunting for a job. And I got a phone call saying that I had landed a job at Johnson Space Center, and they were going to pay me to work with this beautiful habitat over here in the corner called the Human Exploration Research Analog, HERA. I couldn't believe it, but somebody was actually going to pay me to do this. Now, HERA basically works with crew of 4, and they create a realistic environment to simulate long-duration spaceflight so that we can study the psychological, the personal, the team, different engineering concepts, and really figure out how to keep astronauts happy and healthy for long-duration spaceflight. I started, after working with HERA for a couple of years, I started to look around. I realized I wanted to continue to expand. Over the course of 5 years, I had gone from a biologist who didn't think they could get into the spaceflight field to somebody who was here working at Johnson Space Center, and I knew I wanted to continue that. I started to look around, and it took me about a year, and it took me talking to a lot of different people to finally convince somebody to let me work with real spaceflight systems instead of analog or simulated spaceflight systems. And I got a job with the Crew Systems Group. Yes, you can see in the corner here, the Crew Systems Group does do the space toilet. That's correct, yeah. And my family is going to buy me a set of plumbing tools for Christmas. That is 100% on their list. But we also deal with habitability, crew quarters. We're starting to work with some of the commercial crew and Orion, and it's a really exciting time to be able to work with these types of systems. I'm not really sure what. So I just want to leave you guys with a quick idea here. One of the things that really helped me move forward in this field and get the opportunities that I got in such a short period of time was that I was willing to just show up. I was willing to learn from the people around me, and I was willing to do work that wasn't necessarily really, the rock star type work. But what it did was it enabled me to get opportunities that ultimately let me work with some really, really awesome space systems and some amazing teams. And I am so excited to see how all the LEGO League teams are going to do. I'm excited to follow you guys, and I can't wait to hear more from you. Thank you.
Thank you so much, Tiffany. All right, and Chris, you're next.
So as Casey said, it's good to talk to you guys. My name is Christopher Matty. I work here at Johnson Space Center on the Orion program currently, also on the ISS program. Nice overview shot there. Originally started out working in wind tunnel testing with prototype aircraft. So this is actually a very large wind tunnel facility in Winchester, Tennessee, or between Winchester and Tullahoma, Tennessee. It's called Arnold Engineering Development Center, AEDC. That wind tunnel, the big circle you can see in the background there, that's actual size pretty much on the screen. You can see the guy right there is about 1-to-1 size. So this wind tunnel is about the size of 6 city blocks overall. And it's capable of going up to very high speeds, approximately 4 times the speed of sound. But you can see the difference on the, let's see, right side there is the F-35 at the bottom. And then up at the top is an F-18. We're actually doing laser velocimetry. You can see the green where the air is coming off of the aircraft and being analyzed by the laser so you can see what the flow is doing. So that was kind of where I grew up and where I started my internship during my early years. From there, I moved out to NASA Langley out in Virginia, and from moving to NASA Langley through wind tunnels, moved over to the spacecraft side working on Space Shuttle and ISS. So to ISS, I am an expert in what we call environmental control and life support, ECLIS, which are the systems that clean the air and let you breathe in space, which is obviously important for humans. You can see on the right side is Scott Kelly working on the CEDRA, one of my favorite systems, which is the system that removes the CO2 from the atmosphere on ISS. If you have read Scott Kelly's book, you'll know there were a lot of issues with that system. There continue to be a lot of issues with that system, and so it is there in its natural state, which is being worked on. But yeah, as you can see there, we've got it strapped to the floor of the GEM module, and we're taking it apart and working on it. Other work I've done, so if you fix spaceships long enough, they eventually will ask you to fix other things. As you may have seen in the news, there are some issues with fighter aircraft breathing systems. They've had issues with pilots getting sick, having symptoms when they're flying in these high-performance jets. So we were part of a congressional commission to independently assess and evaluate what's going on with those jets. As part of that, they flew us out to pretty much everywhere they fly the F-18 and do aviation for the U.S. Navy and several Air Force sites. The big picture in the back there is taken on the USS Dwight D. Eisenhower, the Ike. We were deployed to this aircraft carrier for 3 days and got to go around during active flight operations, interview pilots, talk to the aircraft operators, and see kind of what they were dealing with. On the left side there, you can see me with a grab sample container, what we call a grab sample, which is a little vacuum cylinder that we use to analyze the atmosphere. I've just taken a shot off of the exhaust of that jet, so I started about 50 feet behind it and then walked up very slowly behind it. You'd think walking up behind a jet that it would just get gradually warm. So Dr. Plyle, the guy standing there with me, kind of jokingly said, well, you just start walking behind it and you'll know when to stop. So I figured that would kind of be like walk up and get warmer, warmer, warmer. Actually, walking up behind a jet, it's like cold, 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 ow, hot, 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 hot. And so when that happened, I just opened up the grab sample and held it up and then got the heck out of there. So yeah, that was pretty interesting. On the right side, you can see another project that I consulted on, which is the NASA's low boom flight demonstrator, working to see if we can mitigate the sonic boom. So rather than getting like a real loud boom boom, you would get something more like a thump thump thump. So you could fly a supersonic aircraft over people without blowing everybody's windows out. So that's yet another thing that NASA's working on and another thing that I consulted working with. Also, test subject, as both Tiffany and Anjay said, we are all members of the HERA mission, the Human Exploration Research Analog. You can see in the back there the HERA module with our crew standing in front of it. Also me playing the guitar while in HERA. Got to find things to do when you're isolated in a chamber for an entire month by yourself, so it's one of the many things. On the bottom side there, you can see me testing out one of the glove boxes. So we have glove boxes that we can draw down to vacuum, and we use to test different glove designs here. So I'm testing some advanced gloves. You have a little busy box in there of things to do, of little tools to manipulate and little projects to do, kind of like a baby toy. But for this case, it's can you make this work with these big astronaut gloves on? And then on the left side, you can see me doing testing in one of the MESA's suits, one of the astronaut vehicular suits, not the suits that you would use outside the spacecraft, but the suits that you use inside the spacecraft to keep you safe during spaceflight. So other personal things, as stated, I really love machines. I like the idea that machines are basically what I would call a will multiplier, right? Machines exist because somebody had an idea for something that they couldn't do. They wanted to go faster, farther, stronger, go higher, and they made a machine to do it. So these are all things that I like to do, but a lot of them are evolved around machines, right? So you can see a quadcopter drone there, a little quadcopter drone, so you can race around your house the size of a butterfly, and then you can drive really fast in a race car. You can fly up into space. You can see on the right side there, that is us ice diving up in Banff, Canada earlier this year. So diving into water that's at the freezing point down below 2 feet of ice, where again, really you would die if you didn't have a suit on. So those kinds of things, which goes into my kind of personal philosophies, right? The world is manipulatable. Anything that you want to change, anything that you can imagine, you can do it, right? Anything that somebody else knows, there's no reason you can't know that. The only reason anyone knows anything is because they took the time to learn and they took the time to put the discipline into learning it. And then also, the world was not built by atomic supermen, right? I mean, any machine, you hear all the time people say, well, that's not supposed to go like that. Well, who says that's not supposed to go like that, right? It's just a machine. It's just metal and plastic and wires. If you know how the machine works, you can make the machine do anything you want it to do. And you can make new types of machines that have never existed before. So don't let the boundaries or the fear of what's out there stop you. And that goes to my final point, which is never, ever give up, right? Failure is part of the process. When you fail, that's just you learning, right? And know that when you fail, if you try anything, you are going to fail, and you're going to fail a lot, and it's going to hurt. But don't let that stop you, right? The whole point of between failure and success is whether or not you stopped when it got hard. It will get hard. I guarantee you it will get hard many, many times. But so I really like the upside down race car because, again, if you look at the data traces in a lot of professional race car drivers, you'll see when the car is upside down and flipping through the air, they're still pushing on the pedals. Even though the wheels are no longer on the ground, they're still working the gas and the brake because until that car has stopped, there's always a chance you might end up back on your wheels. And if you do end up back on your wheels, you want to be driving or you're not going to win. And so you've got to always, you'll know when you fail, right? When you fail, don't give up because it's getting hard or give up because you anticipate that you might fail. You'll know when you're dead because you'll be dead. So as long as you still got energy to move, as long as you still have a ability to move and keep going forward, by all means, keep going forward. And you'll see that, again, through school, through life, through job, everything you do, there will be things that try to stop you and people that try to hold you back. And all you have to do is say, no, I'm just going to keep going through that. And so, thank you. That was pretty much me.
Thank you so much, Chris. I know that applies a lot to our teams this year because they're going to fail a lot. They're going to try new programs, new robotic designs with their new space field this year, which is going to have a lot of interesting challenges as you work through this process. So that's really, really great advice. And so now we're going to dive deeper into discussion because along with your robotic game, you also have your core values and your research project. Woohoo! So that's why we put together this awesome panel of experts is to help you get ideas if you don't have ideas yet, or to help you glean more information that will help support your solutions to overcoming problems with space exploration. So I think to start off, why is the space industry so cool to work in?
I think the best way I can put it, if anybody's ever seen the TV series Firefly, I don't remember the exact quote, but Wash says something about sci-fi, and Zoe looks him dead in the eye and says, "Honey, we live on a spaceship, dear." And I mean, that's really it. We're getting to work with spacecraft. We're getting to work with astronauts. We're on the cutting edge of technology and science. We're making discoveries. Back when I was working on Spitzer, we were finding planets around other stars. I mean, just being able to be a part of that, enable that for the scientists, I don't know, just, it's very motivating.
I can say, really, working in this field, there are just endless number of possibilities and directions you can go. You can hear just from the 3 stories here. All of us have done different research. All of us have come from different angles, and that's just the inclusion of space and space research and the direction that we're going to go is amazing. Humanity being able to branch out and really see themselves living and being in the stars is just the coolest thing.
Yeah, kind of what both you guys said. For thousands of years, people have been looking up at the sky at night, and looking at all those points of light out there and thinking, how can I touch that, right? Even from the point when initially people thought that that was just, a few 100 feet up there. If you had a really long stick, you could like poke it. And then, as we learned more and more and more, we found out that that's, billions and billions of miles out there. And those things are actually all way bigger than our own planet that we live on. But again, building machines and really helping to realize that kind of universal human dream of what does it take to actually go out there, to go out and touch those things that I'm looking at. So
it's exciting. And with your research this season, it's very exciting because you are trying to identify physical and social problems faced by humans during long-duration space missions. And the NASA's Human Research Program recently released 5 major hazards that astronauts will encounter during long-duration space missions. These include radiation, isolation, multi-year missions due to the distance from Earth, lack of gravity, and a closed environment, like what you all have experienced with Hera and high seas. So let's start off with radiation. Why is it such a hazard to humans when we go beyond Earth?
So as some of you guys may be aware, Earth is pretty well protected. It has an electromagnetic shield based off of that really provides additional radiation protection for our astronauts who are in low Earth orbit and orbit around Earth. As we begin to extend out, we will start to receive increased solar and galactic cosmic radiation, which can be really damaging for human health, as well as for some of our electronics and systems. So developing and designing spacecraft that can protect not only the person and the system, but protect our hope for a mission to expand will be really important.
Yeah, and the universe, is not only extremely, extremely big. We are a tiny, tiny speck in the universe, but the universe is extremely, extremely high energy, which also, so 99.9% of the matter in the universe is plasma, right? Is what you see in the sun or what you see in like a fluorescent light bulb. Energy that is such a high state that you could never touch it because it would just, vaporize you instantly. And so the matter that exists as solid liquid gas that we interact with is actually only a very, very small part of the matter in the universe. So when you go out into deep space, this vacuum of space, even though we think of it as empty, is very, very high energy. And so you've got particles that going through you, just being exposed to these particles changes the structure of your body in a way that's not healthy because, as everybody knows from comic books, as Anji says, radiation is not good for you. And so we have to build machines to deal with not only the very vast expanse and the very big size of space, but also the very high energy state of space and kind of protect us from that.
And I think what Chris was mentioning there is in our run through, I mentioned, in comic books, radiation turns you into the Incredible Hulk. You get superpowers and things like that. Unfortunately, that's not how it works in real life. You get burns, you get cancer, you get radiation sickness. And so part of our responsibility of sending astronauts into space is we have to keep them healthy, we have to keep them protected. So we need to make sure that the radiation out there doesn't harm or kill our astronauts.
Are there any ways or developments that have come up so far to help protect astronauts from radiation?
So currently, a lot of the current technology revolves around mass ablation. So you're talking about like having large sections of metal or large volumes of water. Water is specifically a really good absorber of radiation. And so having large amounts of mass that you can effectively get behind that acts as a shield for those particles coming through. We are working toward more of a model of an active type system where you could have something effectively like a shield in Star Trek, right? Where you could have an energy field around you that is then protecting you from the radiation. But that is in very, very early stages, and that's not really developed to the point where we could use it yet. But going to deep space, there's only so much mass out there, so you're almost certainly going to need something that you can develop just from an energy state.
So, and I want to say radiation protection is also important when you are on a planetary surface. And so some of the technologies that we're looking into is how to develop what they call in situ resource utilization. So basically how to use what is already on the moon and what is already on Mars or any other destination that we may go to. I had the opportunity when I was down at Kennedy Space Center, I was visiting a friend and 100% nerding out, touring every facility I could. And they brought me into this room that had a room-size 3D printer. And it is used to try to print the shell for habitats. So the thought is you would take an inflatable habitat inside, and around it you would print different material, whether it be lunar dust or regolith, Martian regolith, so basically the dust and ground that you find there. You would print it around these structures to provide additional radiation protection so that we could really lighten the amount of weight we have to take with us.
And they're mentioning minimizing mass, minimizing weight, and that's something y'all have to consider as engineers is, you know, if you've ever been to the dentist's office and gotten an x-ray, they put this heavy lead vest on you to kind of protect everything they're not taking a picture of. And that works here on Earth because you don't have to lift it up. But once you start talking about space flight, sure, the easy solution is just launching, you know, tons and tons of material, but that costs money, that costs fuel. Your rockets may not be large enough to carry those things. So the reason we're trying to get these lighter materials, sort of lighter ways of doing it, is because every pound of mass you launch into space costs you money, costs you fuel, costs you space. You know, that could be mass that instead of carrying shielding could be an experiment instead.
Yeah, and Tiffany, you mentioned, going to the moon and Mars, and for long-duration space missions, astronauts are going to have to be committed for 2 to 3 years for some of those. What would a crew need to pack in order to be self-sufficient and survive for that amount of time? Everything but the kitchen sink?
I mean, there's a very practical answer, right? They're going to need a lot of spares of the components that they need to ensure that they can live. And that's a question that's still outstanding. We're still not sure, should we send spare material so they could print what they need? So if they needed a wrench, could they print it? And those are questions that are still being answered today. But one of the important components that we're looking at people taking with them, really besides just food and water and air, is, and this is going to be a little hokey, guys, but a sense of team. That's also extremely important and maybe one of the most important components.
And I think one thing there too is, on the one hand, you need everything because there's no Walmart on Mars. You can't just go and buy things. Yeah, but on the other hand, you're not taking as much as you think. And what I mean by that is, think about all the stuff you have in your house. Think about all the things you keep. Well, I guess I'm living in Denver, we have basements. Here we've got attics. But think about all that stuff you have in your attic that you're keeping for that one day you're going to bring it out, or holding on to it for sentimental value. And then think about how many times you've actually brought it out of that attic. A lot of being in an environment like this is kind of trimming down, kind of just realizing what it is that's important, what it is that you personally really need. You kind of learn that you can survive on a lot less stuff than you actually have. It's actually, after my mission, one of the things I did was kind of get rid of a lot of stuff that I didn't use anymore and realize kind of the stuff I did use, the stuff that really was important to me. So you learn kind of to live maybe a little bit leaner, a little bit more sustainably.
So you're saying we shouldn't bring our Christmas trees to space, is what you're saying? Yeah.
Maybe a small one. I mean, it's still good to have that sense of home, but if you're going to bring it, make sure it's a thing you're going to use.
Not to steal questions from you, but out of curiosity, so I know when I went and did an analog mission, one of the things that I thought was really important to bring for myself were, photos of family and friends, but I also brought some fun items. Like I brought ping pong balls so that we could, and paddles so that we could set up some form of ping pong. Did you guys bring anything like that with you?
Well, yeah, obviously I had my guitar up there. And then, we brought games. We had a bunch of different games. And then I packed a lot of mechanical things. I packed a lot of zip ties and tape and stuff like that so that I could fix the vehicle as needed, yeah.
I had a Lego Mindstorms kit, and if you've ever... I wanted to work... Yeah, there we go. If you've ever done sort of the default robots in there, there's these things that kind of shoot little plastic balls at people or go up and bite on things, and I kind of got a little bit of a reputation for being a mad scientist. They thought I was going to lead a robot invasion of simulated Mars, so yeah, there was that.
Tiffany, I'm really glad you brought that up. It's really neat to hear some little things that you took with you, because isolation is one of those aspects of long duration that's really, I'm sure, hard to overcome. What were your experiences with High Seas and Hera in regards to isolation and how you felt through those missions?
For me, I mean, I found that after a while, you very quickly kind of both shrink and grow your mind to fit the space. So your spaceship just becomes just like your house or like your town. And so you think about, you think about other places, right? You think about places outside the spaceship, but you think about places outside the spaceship in the same way that right now you think about like Shanghai or Saturn, right? I mean, they're there and you know they're there, but you're not going to go there right now. And so your entire world is just this spaceship. And at the same time, I felt like that also grew the space, so that even though I would be like, hey, I'm going to tell Casey something, but I'm going to wait till he comes back. But he's not gone. I mean, he's like just sitting like right over there, but he's doing something else. And so I'm going to wait till he's done doing that and wait till he comes over here close to me so I can talk to him again. And so the entire spaceship, you also kind of compartmentalize it into its own world inside there, and you think about just the entire space differently, where it is literally your whole world inside that spaceship.
One of the things about this isolation, too, is you're isolated physically, but the flow of information is also isolated as well. So whenever we send spacecraft out to Mars, we're not going to be able to communicate with them in real time just because of the distances involved. It takes a certain number of minutes for radio signals to kind of travel that distance. And so we simulated that. And what that meant was kind of keeping in touch with the outside world was a very difficult thing to do. All you could do was email. So here on Earth, if you can't get a hold of somebody, you can walk in their office or go visit their house and talk to them, give them a phone call. You don't have those options there. So it's much more difficult to maintain that connection with the outside world. There's a positive to this, though, too, in that there's a lot fewer distractions as well. You get a lot more done whenever you don't have YouTube and Facebook there to distract you. We would get that mode every once in a while where somebody would think, I want to take a break right now, and would try and go to YouTube and then realize they didn't have it and go, well, I'd better get back to work then. So it gives you this sort of, it's almost like living in a monastery where it gives you sort of this hyper focus on this thing you're working on. It's a very cool environment to work in.
And I think that's key, that word you just said, hyper-focus. So I've been lucky enough to both be on the outside and run analog facilities, as well as be on the inside and be a crew member. And so that gives me a very unique perspective. I can tell you, when you are on the outside, you can look at it and you can see these people hyper-focus on problems that you're like, why are you upset? It's just, the sign is just backwards. It's okay. Like, it's gonna be okay. But they have nothing else. There's not a whole lot of social entertainment. There's not a whole lot of interaction. And so it's kind of one of those things that just niggles at the back of their minds. It just kind of stays there. And so a lot of times they bring up stuff that to us, when I go home, I go for a run, I walk my dog, I have a good time. But they don't get that. When they go home, they get to move 10 feet over and still see that backward sign. So it's something that's very important to really recognize, is that it's an environment that doesn't allow a lot of introduction of stimuli, whether that be socially, psychologically, or even like physically and mentally. So there's exercise is different, how you would normally react to things that make you upset or angry. All of that changes. So I just briefly, when I was inside as a crew member, we had an event where our treadmill, we were all such runners, we ran so much that we burned up the treadmill and it died. This was the saddest day. You could see all 5 crew members just kind of sitting around staring at this slightly smoking treadmill, like head in hands, like, oh my gosh, what are we gonna do now? We have 32 more days and there's no treadmill. How are we gonna get through this? And after a couple hours, I looked at my crewmates just so upset, and I thought, we got to get out of this rut. We're not functioning, we're not working, we're not really doing what we came here to do. And so I did something that for me was very traumatic. I put up my last Snickers bar, and I held a competition. I basically set up part of our habitat, and I took string, and I said, okay, we're going to run an obstacle course. And if you touch the string, you get docked points. And we'll run it for as many times as you guys want, but whoever has the fastest time at the end gets the Snickers bar. And I can tell you, just being able to help the team shift focus was vital. We were able to get back on track and stop thinking about our poor, slightly smoking treadmill.
If I could comment on that hyper-focus a little bit more, for me, it didn't even go away whenever I slept. So, I mean, just like anybody, whenever you dream about things, and it's not necessarily where you are right now. So I'd dream I was different places, and then at some point, my brain would kick in and go, wait a second, how are you here? You're supposed to be in a dome on the side of a mountain right now. And, you know, I'd get worried because, oh, I somehow escaped the dome. I'm ruining the science. And then would wake up and see I was still in the dome and go, okay, I'm still here. And so, I mean, that hyper-focus, it's real just because, I mean, that's the environment you're in. You're in this very motivated, very focused environment.
I can remember we actually tried to map out in our heads where the nearest Domino's pizza place was. And we were like, that's only a 52-mile walk. We can do that.
You can achieve that dream. Right, Chris? All right. So it sounds like we have to take care of the squishy pink thing, otherwise known as the human, in these missions. It's very important, both mentally and physically. But we talked about the radiation. I want to kind of spiral back to the human body. And what are some of the impacts when we change gravity fields on the human body when we're out in space or on another planet?
So to some level, we don't actually know. So our data points right now, we know how we act in 1G here on Earth. We know what happens in 0G out in space, and there are a lot of physical effects that take place. Your muscles and bones degrade. The fluid levels in your body decrease. Things happen with your eyesight. These are a lot of detrimental effects to the point where when astronauts come back to Earth, they have to rehabilitate, learn how to walk again, regain the strength in their muscles and bones. We don't know where the cutoff point is in the middle, though. We don't even know if it's sort of a gradual drop-off as you take away gravity or if there's a cliff somewhere. So there's, you know, I think it's a place we need to research a lot more, is figure out what happens to the human body when you're in 1/3 G. It's very difficult to be able to do that research because there's, you know, we could go do that on Mars, but then we're at Mars already. So it's sort of a bit of an unknown right now.
But I think it also really, I mean, it is a challenge, but it also really points to the amazing resilience and adaptability of the human body. Because even after being in space for just about a week, your body says, okay, well, this is where I live now. I better start doing things to adapt to here. I guess I don't need all these bones. I can like start getting rid of some of this bone and getting rid of some of this muscle, right? And we have to fight that, especially on ISS and if we're going to Mars or going to the moon, we have to fight that because you know that you're going to end up back in gravity again, and you've got to adapt so that when you step on Mars, your leg doesn't shatter when you step down. But there's also the case where we are going out into space one day, hopefully to never come back, right? Going out into space to live and not come back to Earth again. And it's amazing that even in a very short time period, your body starts to adapt and change to that of, well, this is where I live now. And so hopefully even going out to Mars, going out to deep space, our bodies, we can find ways to work more in sync with our bodies to say, okay, this is kind of what I need to adapt my body to live optimally in this new environment. I think that's really amazing that even just kind of out of the box, our bodies are already kind of built to adapt like that a bit.
Oh, geez. And I'm the biologist, guys. Those answers are amazing. I mean, I couldn't have said it better.
How would they adapt to, it can be considered a hostile work environment, different levels of CO2, biofilm. What are some of the strategies to help astronauts deal with those situations in long-duration spaceflight?
Well, I think for me, the most important thing when these challenges hit you, and it applies to a team also, is that understand it's not about you, right? It's not, when there's a problem, when there's a conflict in the team, it's not happening at you, right? Somebody's not disagreeing with you just because they hate you and they really want to get you, right? And so it's easy even when things happen, right? I mean, when you're in a vehicle and you're working on a system and the system breaks and you're like, oh, that system broke on purpose because it really wants to get me. And then you're like, ah, and then you go over and then you spill something. You're like, oh man, and But just to know that that stuff is not happening at you, right? That stuff is just stuff that's happening. And the same with your team members, right? Your team members are not doing these things to get you. They're doing these things because you are human beings and you have differing ways of viewing the situation. And so you have to kind of remove your own emotions and your own anger from that problem and know that we're all working toward the same goal, right? None of us want to fail. We all want to be successful. We just may have different ways of approaching that. And so you have to kind of take yourself out of that equation and just kind of look at it as objectively as possible and work kind of together as a team to achieve the common goal.
Oh, and I mean, we are always trying to develop technology and machines to help us be able to do that, even in dealing with the person, right? So we're working with trying to develop closed ecological systems that can not need any extra input of oxygen or water or food. The same kind of goes for people. We're trying to create these microcosms of society where they can get all of their needs fulfilled and they don't actually need external input from Facebook or Twitter, that they're still okay socially, mentally, and emotionally.
Yeah, so kind of on the opposite side of that question too is there's certain things you face, but one of the things that kind of interested me are there's certain things you don't face while you're in there. So all the bodily bacteria and germs, you have kind of what you take with you and that's it. So there's no flu season on Mars. There's no colds on Mars. So my year in high seas was probably one of the healthiest years I ever had, just because we weren't getting these viruses coming in. I got sick twice. Once was from eating something that didn't agree with me, and I had a slight immune reaction to a tetanus shot I got before I ended the mission. But I mean, these were things that were kind of induced. They, again, no flu season. So it was kind of this healthy environment almost.
So Chris, you mentioned teamwork quite a few times, and these teams have a long road ahead of them this season, and they're going to have to work together, communicate, collaborate. So how important is teamwork to accomplishing the mission?
Teamwork obviously is very important to accomplishing anything, right? I mean, not just the mission, right? I mean, even working with your family is a team, right? Your friends are a team. And so it's about, again, understanding that our differences and our disagreements are not actually problems. They're the things that really make our team stronger and make our team work better together. And so understanding that your different team members have different capabilities, different ways of viewing the problem, and that's not an obstacle to be overcome. That's a tool to be used, right? If it's just you, there's only so many ideas that you by yourself can come up with. But when it's you and another person, then you together are now coming up with all kinds of different ideas that even each of you individually would never have come up with. And then you add another person, and it just exponentially multiplies how many ideas and how many solutions you can have to any given problem.
I mean, like Chris said, and like I think we've been saying, team really is one of the most important components that you're going to have in what you guys are doing or in any endeavor that you may seek to move forward with. And one of the really important aspects to that is being able to understand that, yes, disagreements are going to come up, but if you can understand not only what it is that you need, but what it is that that person that you're working with needs, if you can understand, okay, you guys all came to the table, your ultimate goal is this end point, but all of you need different things along the way. And really understanding the needs of your teammates and understanding what the ultimate objective is will be very helpful in accomplishing it.
So speaking kind of directly from experience on this too, it's I think well known at this point that high seas argued a lot, and there's a lot of podcasts and books and things like that out there. But one thing that I think all of these things missed was there's kind of more than one aspect to cohesiveness. There's personal cohesiveness, but there's also task cohesiveness. So one thing, all the arguing and disagreements aside with my crew, one thing that really impressed me about my crew was whenever something needed to get done, how we kind of had the ability to put aside all those differences and get the task done. Again, I think we had a lot of work to do interpersonally, but I couldn't have thought of a better crew for actually just getting down to business, getting the work done. One I remember in particular was we were waiting for a water shipment to come up to the island, and the truck broke down, and we hadn't planned for that. So there was an emergency water supply outside that we could pull from, but that water needed to be purified. So without kind of even any coordination with mission control, team got to work. A couple of the scientists went off to the side, started using kitchen equipment to set up water stills. A couple of guys started getting their suits on. The team came together, was able to put aside those differences and keep ourselves essentially surviving while they fixed the water truck. It took them a day to do it. So that, I don't know, that was just something that really impressed me about my crew, was the ability to do that no matter what was going on.
So in summary, teamwork makes the dream work, right?
Yeah, that's a good way to put it, yeah.
All right, well, space exploration is no easy feat, obviously. From expensive rockets to escape Earth's gravity and keeping the squishy pink thing, the human, alive for a long duration of time in an environment that does not support human life, really. Why do we do it? Why do we explore space?
I think that goes a little bit to just human nature. It is our nature to kind of explore, and curiosity drives us to want to know what is beyond the next mountain, what is under that rock. And so I think historically you can see where this has been really beneficial for mankind and has kind of led us to evolve into the society and the level that we're at now. And I think spaceflight really provides an opportunity for us to continue to expand. It provides an opportunity for us to push our boundaries and see what is beyond the next planet or what's in the next universe. Pardon me, solar system. Although next universe too, maybe.
From a very sort of practical point, and I think this is something that, people see the space program and think, oh, we're shooting dollars into space, and it's all those dollars are spent here on Earth, and it's spent pushing technology, pushing understanding. I mean, whenever you put astronauts in space, at the core of that, you're learning about human survival in an extreme environment, and that's technology that comes back. The space program, that was kind of the first testing ground of something called a Kalman filter, and that's a thing we use in controllers for all types of machines now. There's been advances in medicines to treat osteoporosis that have come from trying to keep the astronauts healthy on orbit. So, we're pushing sort of into this almost sort of science fiction sort of area, but from that, we're solving problems we have here on Earth. It's a way to kind of push ourselves. It's almost a testing ground for these new technologies that ultimately make life better for everybody.
Yeah, and as Carl Sagan said, Earth is the cradle of humanity, but you can't stay in your cradle forever, right? And when you look at the universe, we are this tiny, tiny speck, right? We are a grain of sand in this giant, giant out there, right? That we have never even really scratched the surface of actually exploring. So we spend so much time here on Earth fighting and disagreeing over our differences when there is so much more to be utilized by working together to, again, not see our differences as a problem, but see our differences as an opportunity, as a tool to be used. And so that we can go out to this giant, vast, untouched wilderness that lives out there, and go out there to live and to explore and to grow ourselves universally as a human race.
Well said, all of you. So as we wrap up here, what are some of your favorite stories from working at NASA?
So I'll say, the first time I was in what they call the space shuttle processing facility, where when the space shuttle would come back, they unload everything and they would bring it all into a room. And I mean, I've seen spacesuits before, I've worked with spacesuits, but when you see a spacesuit roll into the room that minutes ago was actually in space, and days ago, like yesterday, was being used in a space flight, when you actually see that spacesuit, you're like, oh my gosh, I want to touch it! And so just having the restraint, but feeling that childlike wonder, oh my gosh, it's a spacesuit that just came from space. I mean, I try to never ever lose that, right? And so when I'm feeling down about working about whatever problem I'm currently working on, just to go and see the spacecraft and see, I mean, here at Space Center Houston, right? Just go and look at these spaceships and remember what it was like to, remember that feeling of this is why we're doing this. And that's just connecting into that is really an important part of the whole thing for me.
I can remember kind of one of the coolest things I've done in my job, and it was when I was a trainee for what's called real-time operations. So we're one of the guys who's sitting on the console and sending commands to the spacecraft. The one I was training on at the time was the Mars Reconnaissance Orbiter. So this is a orbiter that's orbiting Mars in a polar orbit, has a suite of different instruments on board, including a camera called HiRISE. And I remember I was still a trainee, so I was sending commands. I had another, our call signs were ACE, so I had another ACE over my shoulder watching what I was doing. And one of the uplink summaries I got handed was something that said Horowitz Crater Special Observation. And I knew nothing about this other than, the information I needed to load it into the command system and send it to the spacecraft. So, still sort of this nervous trainee sitting on console. Got my goes from the systems engineer to send the command and, sent it. And then after hitting the go button on that command, they looked at me and said, "Congratulations, you just took a picture of water on Mars." What they were doing, this was sort of some of the final pictures in a series they were doing. They call them, I think, surface lineae, where the water on Mars melts and kind of causes these streaks on the planet to form, and those are visible. And at that point, they kind of knew what they were looking at, but we weren't allowed to tell anybody yet because they needed to do the final observations. So just being this trainee and all of a sudden being told that you took a picture of water on Mars and you can't tell anybody for 6 months until they release the reports. I don't know, it's just one of the most amazing experiences I've ever had in my career. Just, again, cutting edge of science and finding things that people haven't found before.
So those are two examples of why it is amazing, is that every single day you have these awe-inspiring moments, whether they're micro moments or full-on moments. You have moments where you're looking at these systems and you're taking photos of water on Mars, or you're touching a spacesuit that was just in space. And I have some similar stories where I'm sitting there in Hera and we're getting ready to ramp up for this item called Space Week, which is where the astronauts come and they use Hera to prep for EVA, so the extravehicular activity when they're in the spacesuit. And I can remember, I'm a suit person, right? So I can remember sitting there, and I'm not really supposed to be at Hera, but I had a few things to finish up, and they wheel in the suit, and then they leave it unattended. I couldn't help myself. But one of the most amazing things of that was I went over, and of course you have to touch it, right? And so I'm looking at the suit. The most amazing thing to me, though, was nobody went, "Stop that." Instead, somebody said, "Hey, do you want to take a closer look?" And that's one of the most just wonderful things about working here.
Those are amazing, and it's so cool to be able to hear your stories and kind of live through them a little bit and kind of get a taste of what that's like. And you all have done the analog missions and the habitat. So if you could go to Mars and live in a habitat for a year or two, would you do it?
Yes,
Absolutely, yeah.
100%.
Yeah, that's part of the reason I did the missions. I wanted to know if I kind of understand the hard part of being an astronaut, see if it was something I was looking at with rose-colored glasses. After doing it, I can say absolutely yes.
So I say yes, but I say yes with a bit of a caveat in that I would go in heartbeat if they asked, but I also know how important team is, right? So I know that it may be best for me to be a member here on the ground. That may be the best way that I can support. Fingers crossed it's not, but if that is, I would be extremely happy just to be able to say that I contributed.
But that's a great point, Tiffany, that the astronauts are always usually in the forefront, and they work hard, they train for years to be able to do those missions, but there are literally thousands of people here on the ground on Earth that support those missions. So even if being an astronaut isn't the avenue you would like to or can follow that path, they need doctors, they need lawyers, they need accountants, they need graphic design. So basically anyone can be a part of the mission. If you work hard, do a good job, and apply yourself, then you could be here and be a part of it.
And I think the flip side of that too is early on in the training for HERA, I realized, one research team would come in and teach me something, and then another completely different team would come in, and then I'd meet the mission controllers, and you realize you're the tip of this massive spear, that there's all these people, dozens for astronauts, hundreds and even thousands, and they're all sort of relying on you to get their data. So it's sort of, you get this feeling of responsibility. But as you said, it's a massive team right now to get those 6 people who are up on ISS to space, or however many we send to Mars. There's a massive team behind those folks.
So as we wrap up, are there any final thoughts for these future explorers that you'd like to share as they work on this year's mission?
I just want to say, when you guys are working as your team and you're working on this mission, be present. Take time to enjoy it. Take time to really engage in it. You're going to learn so much, whether it works or not. And being a person who's not technically inclined, a lot of things don't work for me. But whether it works or not, you are going to learn a lot. So make sure you're present for it.
There's not much I can say other than that. Being a technical person, there is still also a lot that doesn't work for me. So I kind of, one of the things...
That's good to know.
Yeah, they break for everybody. So I think my fellow speakers up here have talked about this too. Don't let those failures stop you. That's just a part of the engineering process, is trying something, finding out it doesn't work, and using that to make a better solution. And enjoy what you're doing, because this is an awesome experience y'all are going to get to do.
Yeah, agreed. When we were your age, we didn't have programs like this. So this is a really amazing opportunity that you guys have, and getting better all the time. And so, yeah, but as Tiffany and everybody said, working on enjoying the experience, being present and realizing how amazing this is. And also, even when you disagree, again, working with your team and understanding how amazing your team members are and how lucky you really are to have them, and to have those different perspectives and to be able to work together with people who disagree with you. So,
thank you all so much. Let's give them a warm round of applause, please. Oh, you're not gone yet. Q&A. Psych. All right, so this time we're going to do Q&A. So if any of y'all have questions, raise your hand, and we're going to speak really loudly. I'll repeat the question, and then we'll have our panel give it their best shot in answering it. Yes, sir, right here. What does it feel like to be in a pressurized suit?
So one of the things that I liked the most about being in a pressurized suit is that, so the suit has a pattern to it, which is, a suit is made to sit in something, which most spacesuits are, a lot of spacesuits, the pattern is actually a sit and not a stand, because if you were standing up when you pressurize the suit, you'd have to push against the suit to sit. And so the suit is actually made to sit in kind of like this position. And so you can, when you've been sitting in the suit for about 8 hours, you can find just kind of the position that the suit was built to, and then just kind of rest there, and the suit will actually kind of hold you, and so you can just kind of go slack and sit in the suit. And I always thought that was kind of fun. And so you can sit there, and your head kind of shrinks down in the neck ring, but you just sit there and actually kind of take a nap. And so you have to be kind of, careful not to fall asleep and maintain what you're doing, but I was surprised with kind of how relaxing it can actually be inside the suit.
Oh, and I can tell you that it's a little different for every suit that you're in. If you're in a suit that's meant for EVA in space, it's going to be built more so that you can kind of sit in that position, that neutral position. Because in space without gravity, you kind of curl up a little bit. Everything kind of comes together, and so if you ever see the astronauts in space, they just kind of, their arms naturally want to float here, and their body naturally kind of wants to curl in on itself. But for planetary exploration, it's going to be totally different. Inside, if you think about a balloon, it's kind of like being inside a human-shaped balloon, and trying to move through that, right? And so you're pushing against the elastic, trying to move and function, and it can be pretty tiring, especially for your hands. And that's something that they do a lot of research into, but it's always a fun day.
I can't tell you about pressurized suits, although I just did my test subject physical to get a chance to do that, but I can tell you at least sort of the analog suits we were using. prior to doing all these things, I played some recreational ice hockey, and I was a goalie. And when you're in a goalie, you're in this big padded suit, very enclosed, a lot of restrictions on your range of motion. And what I found was at least being in those analog suits really wasn't all that different from that. So it's one thing I always noticed in my goalie mask, and in that as well, is you're kind of aware you're in this bubble for about the first minute or two, and then it kind of goes away. And you kind of ignore the bars in front of your face or the mask in front of you. You kind of just adapt to having this thing between you and the environment between you.
Okay. Way up top. Mm-hmm. Okay, so he asked if it's possible to 3D print more than structures, like food.
Well, yeah, I mean, theoretically, it's possible to 3D print anything, right? I mean, the world is just atoms, right? So we're working toward where, you know, right now you 3D print in plastic or in advanced cases metal, but there is no reason that you couldn't have a machine that's just going carbon, 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 nitrogen, nitrogen, oxygen, carbon, carbon, carbon. And so once you get to that level, yeah, you can 3D print anything you want. And really, again, I mean, on our planet as a model, the Earth is a closed system, right? Nothing comes in or out of Earth except sunlight. And so Earth has been living for billions of years like that, with nothing coming in or out except sunlight. So similarly, on a space mission, yes, it should be possible to just rearrange your atoms because it's not going anywhere, right? You eat food and your body rearranges it, and so you can rearrange it back into food again if you wanted to. So yeah, that is absolutely possible.
Oh, you want to go ahead? Okay. So another application of this too would actually be medical devices. So during my my high seas mission was we had a chance to judge a competition, and the idea would be you'd be printing these oxygen parts, so something that would take an oxygen flow, regulate it, and split it into two different patients. And these would be things that would be printable in third world countries by people who had limited resources, basically just a 3D printer and ABS. And we got to test some of those at high seas. Another thing we did was we printed a finger splint while we were there just to kind of test it. But the idea being is, let's say an astronaut breaks a bone while you're out on Mars, while they're out on EVA, and you have to set that bone. It's much better to be able to print a splint to fix that one bone than it is to take a splint for every single conceivable bone you could break. So I think there's a lot of application there, and kind of just being able to print the tools you need. I'm talking about medicine, but also, you know, tools you might need to fix your spacecraft as well, do some sort of exotic fix on your spacecraft.
All right, way up there. Orange shirt. Does space food taste better or worse than Earth food?
So my group, Crew Systems here at Johnson Space Center, they are in charge of the PWD, or the portable water dispenser. And ultimately, that's what rehydrates the food on orbit. So we get a lot of opportunity. We call it training or lunch to try out the food. and it's very good. It does taste slightly different, but it is still very, very good. It tastes very much like what you would eat down here. For me, the difference when I was in the analog world, the food there tasted great, but it was mushy. It was always mushy. It had the same consistency. It didn't matter if you were eating apple or if you were eating rice. It really was the same consistency.
My crew, because we were there for a year, we had a chance to grow some plants. And I'm not talking about a whole lot of them. I'm talking like once every 2 or 3 weeks you get a couple of leaves of lettuce, and that made a huge difference, again, because you were kind of missing that crunch, just kind of, you know, the crispness of a fresh vegetable or piece of fruit. What I will say is space food kind of got a bad rap back in the early days of the space program. So, Mercury and Gemini astronauts were eating pastes out of tubes and little food cubes, and we've had a few decades to get it right since, so it's much better now. In fact, during my Hera mission, I got to taste a lemon curd cake, and I liked it so much I've actually since gone to the food lab and gotten the recipe for it and made it at home. So space food is not nearly as bad as it used to be.
But in zero G too, even the food that your entire body shifts, right? You undergo fluid shift. Also, a lot of the way that you experience the taste of food is through the smell, and because air circulates differently in zero G, you don't have the same olfactory sense that you do on Earth. And so people talk about in zero G, a lot of your sense of smell gets dulled and your sense of taste gets dulled because of that. So if you look at the pictures of the crew eating on orbit, you'll see that they have a lot of hot sauce, right? They have a lot of hot sauce and a lot of pepper, because you really kind of need that amplified sense to really taste the things you would normally taste here on Earth. And so, again, even the differences between space food and Earth food, there's also a difference in just the way you experience the same food, just because you're now in space. So it's a big change.
That's a good question. Got to keep them happy. All right, there's a lot from the orange team. We'll start over here on the end and work our way over. What material was the inflatable habitat made out of?
Yes, the inflatable habs are usually made out of very high tensile materials like Kevlar, things like that, but they've worked with different ways of making different materials. So again, ideally you want something with a very, very high tensile strength like Kevlar. Spider silk is actually one that people have looked at, but then also if you could do long chain carbon structure, so like a real long carbon fiber, which they're also working on. So again, the idea being in a balloon, right, you want something that is holding together that tension structure, and so you want something that's really just a very, very strong string, and then you weave it together into a large inflatable structure.
And interestingly enough, the substance that it's made out of is very, very important, but so is the shape. You'll notice a lot of the inflatable structures do not have corners, and that's for a reason. If you make a corner, it's very difficult for the habitat to withstand the pressures that are being put on it and for it to maintain integrity.
And one of the things, and this especially applies to space structures, is the reason we're having to make these so strong is because we think of space as being high, but it's also very fast. And there's actually a great exhibit out in the center here about what happens when small objects hit things at orbital velocities, and it can do a lot of damage. So we're having to use these really strong materials because we have to withstand something coming at us at tens of thousands of miles per hour. And for the folks who are in kind of more advanced science classes, remember that your kinetic energy is 1/2 of your mass times your velocity squared. So as things get faster, the impact energy just absolutely explodes. So.
All right, we'll go over here. How does it feel like to come back to Earth after a mission? Maybe your simulated Earth.
Well, so for us, going out of Hera, for example, there was certain things that the crew talks about that I also experienced, where you have what they call visual acuity shift, which means you're extremely nearsighted because you haven't looked at anything farther away than about 20 feet in a month. And so when I came out, it actually, looking at something farther away than about 20 feet felt like looking into a really bright light, like really, really hurt your eyes. Also, when you get down, when you get down from microgravity, your body's system that balances all your fluids in your body is kind of screwed up because, again, it's learning how to adapt now to living back on Earth after living in space. And so you get shifts in your fluid where you get swelling and pressures in places that you wouldn't normally get. And so that's a challenge. One of the things that I thought was most interesting is that they talk about when you go to space, for some people it's hard to sleep because you don't have that pressure across your back of laying down that says, okay, I'm laying down, it's time to sleep now. And so you have to relearn how to sleep in microgravity. But then they say the inverse happens when you come back to Earth. where this laying on a sheet in a bed now feels like laying on a sheet of sandpaper because you're not used to having something pressed against your body when you're trying to sleep. And so people say that's real uncomfortable. Yeah, you need a zero gravity bed, exactly.
We're talking about the physical aspects, but I think there's a large mental aspect to it as well. So you go on a mission, either simulated or real, knowing that you're kind of going into this new and crazy environment, and so you're kind of prepped for that change. The way I put it is what was novel becomes normal, and what was once normal becomes novel. So you kind of learn to live in this new environment, and you start to forget what you used to do back on Earth. So whenever you come back, there's certain things you have to relearn. I had to learn how to go grocery shopping again. That was, going from just being issued food to having, hundreds of foods to choose from. How do I pick? I don't know. The other thing is, whenever you're in an environment like that, it's very sensory deprived. So you're not getting as much input. You're not getting as much information. Contrast that where, you're around either 3 or 5 people to going to a shopping mall. All of a sudden, you've gone from this environment which is very calm, very quiet, and kind of everybody is focused on what you're doing, including mission control, to all of a sudden there's all this movement all around you, hundreds of people, and they're not necessarily paying attention to you either, or even kind of, some might accidentally run into you. So you kind of have to get used to living back on Earth, back in society again, kind of relearning old habits, as it were.
All right, we're going to take one more, but don't worry. If you don't get your question answered, they'll be outside in Astronaut Gallery here in just a few minutes. And we'll go over here in the teal jacket. How successful are the plants in space?
So there's several groups that have grown plants in space. And for the most part right now, what they have is a packet system. So they actually send it up so that the soil is all encased in a packet and the seed is already there. So basically you just add water and then the plant will grow up out. And that's come from a lot of experimentation. Because there's no gravity, plants on Earth use gravity to know which way to put their roots and which way to grow up for shoots and stems to find sunlight. But when you take away that gravity, the plants have some difficulty in understanding how they're supposed to grow. Sometimes you will see some stunted plants, but for the most part, they do, like us, they adapt. They tend to be pretty hardy and will adapt to the environment that they're in. Most of them.
A little offshoot of that, as she was saying about adapting to zero G, one of the most interesting, it wasn't a plant, but one of the most interesting experiments I personally watched was on one of the shuttle missions, they flew spiders, orb web spiders, to see what they would do in zero G. And in the very first days, the spider would just kind of go crazy and just make just kind of a gobbledygook mess of web inside the pen. And then they'd tear that down, and then they'd make a little bit of a better web. And then by the third day, even without gravity, there was a perfect orb web now in the middle of their spider pen again, which it's amazing how adaptable biological life is to new environments. So as Tiffany was saying, I mean, plants have to learn how to use, not gravity, right? Have to learn how to use the light instead of gravity now as a reference for this is the way I'm going to grow. But they adapt really, really quickly, and it's amazing how quickly a living organism adapts to a new environment like that.
All right, well, Anjay, Tiffany, Chris, thank you so much for sharing your story and your wealth of information with these teams. Again, if you did not get your questions answered, they're going to stick around for a while afterwards and can answer your team's questions. So thank you all very much.
All right. Continuing on. It's now my pleasure to introduce Jane Taylor, who is the First in Texas East Area Coordinator for FLL and FLL Junior. She also has many accolades for her dedication to education and involvement in FIRST opportunities. Jane is a master trainer for the LEGO Education Academy and a 2016 Google Next Gen Tech Policy Leader. So please give a warm applause for Jane Taylor.
Good morning. Is it still morning? Good morning, everyone. You guys look amazing. I've been waiting for this moment since I joined this organization. to see all of you standing in front of me ready for another season of First Lego League. I am going to be your coordinator for this year, but of course I do not do this alone. So I would like to introduce a few people to you. If I can have our first Lego League senior mentor, Miss Lolly Garay, I'm sorry, Lolly Garay, if you can wave to the crowd. She'll be our first senior mentor, and we have with us also for first. I'm also the coordinator for First Lego League, and as our first Lego League lead mentor, we have Miss D. If you'll wave to the crowd. We have also one of the biggest thing, and I'll talk about this a little bit later, how important volunteerism is. We have a new person supporting our area for volunteerism, and it's Miss Chris Gunter. She'll wave to everybody. Now, and there's a host of our volunteers, both who are parents, who are coaches, who serve in leadership position throughout the region. They're kind of sporadically out there. If you guys are kind of give ahead, our head refs, I think one of our head judges is in the room. If any of our volunteers are in the room, I want to let's give them all a hand, because we know we cannot do any of this without them. They practiced this with me. All right, what I wanted to do, because there are some major changes with First Lego League in the Houston area, is that I wanted to make sure that I went over our new organization, and I'll also be in the gallery later if you have any specific questions about the way we're going to be organized. So I'm going to try to move quickly, because I know that you guys really want to get to our engineers here. I know I do. I have some questions. But one of the new partner for First Lego League is First in Texas, which is the organization that I represent. We have a new executive director, Patrick Felty, and the region looks a lot different now. I know some of your faces are familiar. They practiced this with me. Oh, there we go. Some of you may find this map to be familiar. This is the old organization for First Lego League. Houston was once a part of what was called the Southeast region. You'll see that arrow kind of pointing towards our area. That was the way that the league was organized, and there was pretty much 5 regions, 5 regions in this area. So now the new organization looks like this, and now we are one region. So instead of there being 5 separate First Lego League regions, we now have one large region that we've divided into 4 areas, which is what you hear we now call the ACES region. We are the E in the ACES. We are the East region. So as you are looking for information about our region, you want to reference the East. And as you can see, the East region goes far beyond just the Houston area. The area, the darker orange, is the area that is currently having teams in play. And as you can see, our region has such an opportunity to grow, because we are missing quite a few of the other counties that we want to have in play. So over the course of the next couple of years, we expect that First Lego League is going to grow, and we are organizing this year in anticipation of that growth. The way that the organization is organized is that there are essentially 4 of us. We each have a different area, and that we coordinate, and we are actually competing for spots in the first overall organization with the other areas, because we are one region. As you can notice, of those regions, I wanted you to kind of get an idea of what the other regions look like as far as teams are concerned. This region will have 300 teams, and you will see that we are not the largest region yet. Actually, my PowerPoint turned everything Alamo to East. So the Alamo region actually has 425 teams in it. We're currently at 300, but We do everything bigger in Houston, so it won't be long before we'll have way more teams than them, right? Because you guys are going to get out there and you're going to tell everybody about First Lego League, right? And you're going to have outreach, right? Are y'all out there? Now, y'all know I have too much energy, so we're going to work on that energy. All right. For World Festival, we still have one position that we will have for advancement into the first World Festival, which is will take place here in Houston. So I did want to kind of give you an idea of what our future structure will look like. We are working on creating another opportunity for championships in between our local championships and worlds by having a statewide opportunity. So as you think about growing your programs, next year, it's very possible that next year we will have a statewide convening of the top champions from each of the areas or some of the top teams from each area. We can make this dream, right? Right. All right, I also wanted to update you with some of the things from First Headquarters. One of the major changes or updates is now we have core values across all of the programs that are the same. So if you're in First Tech Challenge or if you're in First Robotics Competition, the core values are exactly the same. And if you will look, one of the newer core values is inclusion. We at First are very, very adamant about supporting with resources and with information the inclusion of all students interested in playing in First. We respect each other and we embrace our differences. One of our speakers spoke about embracing difference, and that is very important this season. One of the opportunities that each team will have in reference to this is the idea of earning a badge. We have a equity, diversity, and inclusion training that I encourage all teams to take. As we go through the season, there will be opportunities for me to celebrate those who can rock this badge, meaning that your team decided that this was as one of our center core values, that it was important to you to sit down as a team and to determine who's not in the room, who you can invite in. One of the key pieces of this training is about inviting people in. If you're anything like me, when I walk into a room, unconsciously I start looking for myself. It could be, are there any other girls in here who have locks in her hair? Or is there anybody else in here who looks like they like hip hop dance? I'm looking for similarities, and sometimes it feels really good when you're invited into a space and people tell you that you're welcome. So inclusion is about that. It's about, trying to figure out who we have not invited into the room. And so going through the training, you're able to complete this badge, and then you can then save the badge and place it on all your social or anything your team has as far as marketing for your team. One of the announcements I want to kind of make is what my huge need. I want to let you guys know my background is in I've been doing robotics for over 18 years, and so I've worked a lot of robotics competition. First is my first family. It was the first robotics competition I ever was a part of in 2001. Mission to Mars. It's a space thing. But one thing I know about First is this, that this is a volunteer-based organization. This is about all of us, all of the adults in the room, all of the young adults in the room coming together to make this opportunity possible for all of our learners. So we cannot do this without you. This is not my first Lego League. This is our first Lego League. So if we're going to be successful, then it is our job collectively to get out and get the word out and recruit volunteers. And I'm going to tell you in a second why we are going to need a lot of volunteers this year. We do have some head positions that are available because we have to double down on our leaders. We are looking for head referees, a head judge advisor, event volunteer coordinator, and a lead scorekeeper. We have those people in place now, and they're ready to train the next person who would like to join, and we would like to expand and have more head judges. So please, there'll be a table outside. You can sign up today, grab some information on how to become a volunteer. If you're thinking of someone else who you think would be a great for that job, please grab the flyer or take a picture of the flyer for them. Here is what you all have been emailing me about. I don't see enough cameras out. Okay, there they are. Okay, thank you. I got a heart up there. Thank you for the heart. Somebody gave me a heart to say thank you, Jen. You're welcome. Just to let you know why you have not seen this information, I wanted to make sure that everything was finalized and was clear before I communicated it out, because it's one thing to tell you these qualifier dates and then come back and change them. But these are all solid dates. Our qualifiers will open on October 1. When does the qualifiers open? Yes, on October the 1st is when you will be able to register for your qualifiers. The way that works, you will be able to rank the location you'd like to go to, and then I'm going to do my best care to get you to the exact one you want to. That won't be the case all the time. You might have to go to your second choice, but everybody will get into a qualifier. Our champion, oh, let me go back. Yay. No, that's not back. Don't laugh. Yay. Okay, well, that was some good energy. At least we're all laughing together. All right. So if you'll notice, we have our East Area First Lego League Championship event. The date is March the 2nd, and it will be hosted by Stafford High School. And we're actually going to be able to have 100 teams playing in the championship. 100 teams playing in the championship. 100 teams playing in the championship. Yes, okay. We will be hosting one of the largest championships in Texas, and it won't be our first time doing it. We also will have a a silver tournament. So for the 200 teams that do not advance, you will have a second chance to play. All right, just some important dates before we get out into the gallery and enjoy the field and our different engineers. We have some coaches event. Next week, you'll be getting an email to sign up for our coaches clinic. So please come out if you need hands-on help with your robot. This is specifically for coaches only. You will bring your own robot, your own laptop, but we will have experts like myself. I'll be teaching the EV3 class, and we have other experienced instructors who will be helping out with the other workshops like Judging 101. All right, and we will also have 2 other coaches clinics, and you can see the dates here that you can attend. My goal is to really help you, and hopefully everybody has my direct contact information, and you can kind of check in the audience. I will get back to you, and I will try to resolve what you're in need of. So please come to the workshops and reach out and let us know that you need our help. That's what we're here for. That's what Miss Lolly is here. That's her number one goal, is to support our teams and to be able to be a phone call away, or if we physically have to come out to you, we can. But please see us as your resource. Volunteer training. Yeah. Okay, whoever that was, you were like my favorite. Yes, you were my favorite person. Volunteer training, everyone. I know, isn't that exciting? We're going to be doing First Thursdays. There are 3 of them. Well, 2 of them are actually First Thursdays, but then we're going to have a practice day which will be a training day for the judges as well. One of my biggest goals is to clean up the judging. We really want to have some fair, consistent judging. All right. And lastly, here are some fun things. Where are all the girls at? Come on, ladies. Hey, ladies. I have a special event that we're having on next weekend right here in the Education Center, where we're going to have a First Like a Girl Build Day. This will not be our only girls event, but it is our inaugural, and our first event is amazing. We have featured STEM women who work in STEM. It is Women in Tech Celebration Day on the 22nd. So we are going to be here. It's a free event. You can register by looking up First Like a Girl on Eventbrite. I will let you know, however, that we literally have a handful of spots. Of the 100 spots that we had available, 78 people are registered. So if you are thinking to come, you might want to make sure you register before you leave this event today. Other days that we'll be celebrating, of course, is Space Professional Build Day. We'll have a build day with the space professionals. We'll be working with the engineering professionals. And if you guys are doing anything fun, please invite me. I love to come out to events and to celebrate what you are doing and how you're doing it. You can definitely contact me by emailing me, but give me a 2-week lead on the event, and if I'm available, I assure you I will be there. All right, are y'all ready to officially launch our season? I don't know. Y'all kind of sound ready. I don't know. I think y'all have a little bit more. This kid here, you're like my favorite kid up there. I need everybody to have that energy. Are you all ready to launch this season? Yeah, that's more like it. That is much more like it. Well, I'm going to hand this thing back over to Casey. I'm super excited. Like I said, I will be hanging out near the table. Please feel free to come and ask me anything you need to ask.
Thank you so much, Jane. All right, so we have an awesome message that we want to share with you from an astronaut on the International Space Station to help you kick off your season. Are you ready? Yeah. All right.
Hi, my name is Alexander Gerst, ESA astronaut on board the International Space Station. From here, traveling in Earth's orbit at 28,000 kilometers an hour, I would like to wish good luck to all First LEGO League Junior and First LEGO League teams around the world. I'm very excited that over 55,000 teams from all over the world will explore space during the Mission Moon and Into Orbit season. And I can't wait to hear more about the innovative ideas and solutions you will come up with. Whether it's for the robot game or the project, remember to work as a team, making the best of all the different skills you have, just like we do at the European Space Agency and here on board of the International Space Station. Keep an eye out for a series of interesting videos, which will be posted on the First LEGO League and First LEGO League Junior YouTube channel for over the next few months. They will focus on many different space-related subjects, and they might be a source of inspirations for your research projects. I wish you all the best from the ISS, good luck and have fun.
How cool was that? Wow! How exciting! What a great way to kick this off. So thank you all for coming here to Space Center Houston today. We wish you all the best with your season this year and your teams, your research projects, your robot build, and make sure you demonstrate those core values. So be sure to check out the new playing field out in Astronaut Gallery. And we also will have our wonderful panelists here to answer a few questions. And I'd also like Dustin Neal to stand up. He is a NASA engineer who has joined us this morning to help answer questions. So a little bit about Dustin. He's been working on the Orion spacecraft since 2007, and they recently successfully completed a series of parachute drop tests out in Yuma, Arizona to qualify the flight parachute system, which is really, really exciting for the Orion program. So you'll be able to ask them questions in regards to your research project here in just a few minutes. Thank you so much, Dustin. So as we wrap up here, we ask that you exit out, come down the stairs and exit down the side doors. And again, thank you for coming to Space Center Houston. We wish you all the best of luck for your first Into Orbit season this year. You are dismissed.